Okay, so that now we can think about structs as kind of like a database record. This is how we actually implement this in C#. Notice here that we have this form1 initialize component like we always do at the beginning of a program when it's WFA. This you should never mess with, but anything between this and, say, for instance, a form load is a variable set where you are giving it the highest visibility within the program. That is, anything and everything can see this particular thing. Now, when we create a struct, we are not creating a variable. We are creating a type that we can use on a variable later on. Now, this variable type here is called contact, and it has first name, last name, city, state, zip, and of course street. You could add date of birth. At this particular juncture, I just didn't want to get into it, and phone number, including the international dialing number. Okay, this is a particular function within the structure, and if it was called, then it could access any of the data within the structure, including private data if there was private data used for calculations or whatever within the structure. Now again, this is not a variable. All of this stuff is part of the overall data type of contact. Now, I'll cover this in a second, but here is where we are declaring a variable called contact, C of type contact, and we say C is of type contact, and we say new contact. These parentheses are necessary, and I don't want to get into exactly why at the moment. It's just not really necessary. Now, this is for button clicks, so that if I run this, when I click submit, it handles bringing in all of this data. Okay, so now all of this stuff under form load here is simply to set up an easier way to bring in the state information. And so when I run this, I have a list box here where this is the state, and I can go here, scroll into something and find a particular state and select it, and it will go back into the program, and you don't have to fill it in or type it in or whatever. This has a better situation because of the fact that if the user only has these to choose from, then they're less likely to make a mistake. Okay, so in the program, these are the choices. It's a lot to type in maybe, but it will keep the user a little more confined and less likely to make a mistake. Plus, if we want to add any of these, then we can just add it into this list, and it will automatically be populated into the list box. Okay, so it goes in here, it clears out the list box, and then it adds them in one at a time. Not a big deal. Okay, so it has nothing to do with structures per se. It's just the way I created the form. Okay, so we've created a structure variable C, and so when we are using the program, we put information in, and then we collect it into the structure variable C. And so the notation for this is C dot, and then we pick the particular field name within the structure. So we pull out the information from the first text box for first name and stick it into that variable. We pull out the one for last name and stick it into that variable, and so forth. These names are the ones that were named within the structure type contact, and they are simply selected at that particular point. Now, on the form, when we pull in the information for the text box for any of the numbers, we have a particular issue that we have to deal with, in that they come in as text and we have to make them into numbers to store, because if you look up here in the contact, they are integers. Okay, and you can't store text into an integer. So as a result, we have to convert them. This is one way to do it, but it's certainly not the best way. In week 5, we'll talk about the best way, because it will check for not having put a number into the text box, or a variety of other things potentially, to protect the user from not filling out fields that you need to fill out on the form. I put a message box at the end of this so that you can see when the submit is finished. Okay, so I'm going to run this, and you know, you could put information into these particular box, and of course the second street thing is not really required, so then you can put in a particular city, and we'll say that that one's in Arizona. And by the way, at the moment you do have to select a state. If you don't select a state, you'll get an error. And then and in the telephone number, again, because it is converted there, and if there's nothing there, there's going to be a problem. So you have to put in some kind of a number. At this point, I'm just putting in zeros, and then when you click submit, then you'll get a message, and this message comes from the portion of the program that is where I called a function within the structure. I'll show you that in just a second. And then when it's done, submit is finished. Okay, so I'm going to close this and show you the thing here. Here's the function that I'm checking. It says if C check values, and that's a function which is in the structure itself, and you can see that that this function is within the structure and not a separate thing within the main portion of the program. I want you to understand that this is special in as much that the function can check not just the public variables, but also the private variables within the function. It can do calculations, it can do whatever. In this case, I just have it send back a false value for a Boolean, and then that is parsed here, where it says, oh, if it's not true, then show a potential error message. It doesn't really mean anything here because it's not fleshed out, but it's just a way to show that you can call that particular thing. But notice it's C dot check values. Okay, so it is calling the function within the structure, but it has to be prefixed by C dot. Otherwise, it doesn't know what it means by check values. That if I take out C dot here, you see that the red squiggle appears because it's not something that it understands. The only way it understands it, is to put it back in with C dot. And also, I want to just mention briefly that when you're selecting something from C dot, if you say C dot, you'll notice that all of these names appear here. First name, last name is here, the phone items here, the state, street 1, street 2, zip, all of these things show up there because it knows that they are pieces of the structure from the variable C of type contact, which is here, okay, and here. Okay, now as I mentioned in the comments here, I want to make sure that you understand that structs are basically an outdated concept. They are static in nature, and now that we're using object-oriented programming in an object-oriented programming language, or sometimes we say OOP language, the tendency is to use the OOP foundation constructs, which is to say we're going to use a class, and classes are similar in nature to structures in that you can have stuff like these variables up here, but instead of calling them variables, we call them properties, and instead of calling this a function, we call it a method. Now, it's not all that different, except in as much as we stop really putting things like the definition of the type, if you will, or the object, the class rather, in the program, and we start placing it someplace else, which I'll show you in another video. And the construct is basically the same, except that in classes, when we declare an object from that class, basically a copy of that class, then what we're doing is we're creating a dynamic version of it, whereas in a structure it's a static foundation. In a dynamic foundation, we can move it around in memory. We can control how it is operated on in memory, and that is a significant improvement in all of this. Now, why would we do either one of these? Why would we create a contact or any type of thing like this? Well, it allows us to move around the entire structure in and out of any particular function / method. We don't have to individually move first name, last name, street 1, street 2. That would be monotonous and difficult. When we have a structure, we can use that type and we can say, okay, we want to transfer all of that stuff. We can transfer the variable C from one function to another, and it transfers all of that data in one movement. Okay, and that is a significant advantage. So we do that, we can do that with a structure, but we can do it even easier in class because of the fact that it is dynamic in memory. Structures are basically going to be eliminated eventually from object-oriented languages, and we're going to use solely classes so that we can use the dynamic memory allocation method. Okay, so this is it for this video.